This video shows an example of estimating concrete works for parts of a bungalow. Learn how here in quantity surveying. The project is a bungalow-type residential building with 3 bedrooms. Instead of the structural details illustrated, the specifications are as follows. The columns are square of 400 mm size. The roof beams are identical with 300 by 350 mm dimension. There are 12 units of 800 mm square isolated footings with depth of 450 mm. The embedded column is 1 meter. The floor-to-floor height is also identical with 3 meters. For the openings, the entrance door is 1 meter with double door. Room doors are 0.9 meters with panels. The T&B and laundry doors are 800 millimeters width. The receiving room has 2 pairs of 0.8 width by 1.2 meter height of sliding windows, whereas the dining room has 2 pairs of 1 meter width sliding doors. The kitchen has 1 pair of 0.6 by 1.2 meters height sliding window, and the rooms have 2 pairs of 0.6 width by 1.2 meter height sliding windows. First is to estimate the concrete works for the foundation. There are 12 units of isolated footing for the project. The size of footings is 800 by 800 millimeters with depth of 450 mm. Compute for the volume with 10% wastage allowance. We use 10% because footings are exposed to the grate. Compute the volume as 1.1 of 12 units of footings times the size of 0.8 by 0.8 with a depth of 0.45. The volume is 3.8016 cubic meters. With concrete mix A, cement is then the volume times 9 bags per cubic meter, giving 34.2144 bags. Sand is then 3.8016 cubic meters times 0.5, resulting to 1.9008 cubic meters. Then gravel is then the volume times 1, which gives 3.8016 cubic meters. Next is to estimate for the materials required for the columns. Just like the number of footings, there are also 12 columns. The column size is 400 by 400 mm. The embedded height is 1 meter, and the floor-to-floor height is 3 meters. The total volume for footings including the wastage allowance is 1.05 times 12 units with 0.4 meters by 0.4 meters multiplied by the height of 1 meter embedment plus 3 meters suspended height. The result is 8.064 cubic meters. With concrete mix A, cement is then computed as the volume times 9 bags, which results to 72.576 bags. Sand is then the volume multiplied by 0.5, that is 4.062 cubic meters. Gravel is the volume times 1 cubic meter, which gives 8.064 cubic meters just the same. Considering that the project is with slab deck roof, there should be complete framing. Next is to estimate the concrete works for the roof beams. From the specifications, the size is 300 by 350 millimeters. So all we needed to compute is the length to have the volume. Start with solving the length of horizontal beams. The gross length turns out as 3 plus 4 meters. But a clear span is computed by taking out twice of half of the columns on both ends, and the whole width of the middle column. The length of the beam is then 3 plus 4 less twice of half of 0.4 minus 0.4 meter. The length is then solved as 6.2 meters. The total length is then computed as 4 units of horizontal beams times the length of 6.2 meters, which is then 24.8 meters. Do the same with vertical beams. The total length of clear spans is computed as the gross length minus twice of half of the column on both ends and also 2 whole column widths. In equation form, the length is then 4.5 plus 3.5 plus 3.5 less twice of half of 0.4 minus twice of 0.4 meter. The length then comes out as 10.30 meters. So the total length of the 3 sets of vertical beams amount to 30.90 meters. Placing the summation of lengths of horizontal and vertical beams is then 24.8 plus 30.9, which is equal to 55.7 meters. Now compute for the volume of the beams, adding the 5% wastage allowance. The volume is then 1.05 times the size of 0.3 by 0.35 meter with a total length of 55.7 meters, which results to 6.140925 cubic meters. With concrete mix A, the cement is then the volume times 9, giving 55.2683 bags. Sand is then the volume times 0.5, which becomes 3.0705 cubic meters. Gravel is then the volume times 1, which is 6.1409 cubic meters. The next task is to estimate the concrete for the slab deck above bedroom 1 using 4 inches thickness. The area of slab can be computed from the gross area of bedroom 1, which turns out as 3 meters by 4.5 meters. To solve for the clear slab area, take out the overlapping columns from the on-center distances. From each column, the overlap part is a quarter of the area, so the total column area to be removed is 4 times 1/4 of 0.4 times 0.4, which is 0.16 square meters. The next member to take out is the overlap beam. Start with the horizontal beams where there are 2 units of half of the beam area. This is twice of half of 0.3 times the length of the beam, which is 3 meters, minus twice of half of the columns. The area for the horizontal beams is 0.78 square meters. For the vertical beams, do the same procedure. Take out twice of half of 0.3 times the length of 4.5 minus the column width, which gives 1.23 square meters. The clear area for the slab is then computed as 3 by 4.5 minus 0.16 less 0.78 minus 1.23 square meters, resulting to 11.33 square meters. The volume of the slab is then computed as 1.05, accounting for the 5% wastage allowance, times the area of 11.33 square meters by the thickness of 4 inches, which is 0.1 meter. This is then taken as 1.18965 cubic meters. With concrete mixture A, cement is then the volume by 9 bags, giving 10.70685 bags. Sand is then the volume times 0.5, which becomes 0.594825 cubic meters. Then gravel is 1.18965 as the multiplier is 1.